Just say your name.
Yeah, my name is David Zuby, spelled Z-U-B-Y.
And where do you work?
And I work at the Insurance Institute for Highway Safety. I'm the Executive Vice President and Chief Research Officer.
So, you were just telling me, David, about crash test dummies.
Right.
And Vince and Larry.
Right.
Is that the beginning of the story? You
Yeah,
saw them and that inspired you?
So Vince and Larry were part of a public information campaign that US DOT did to try to encourage people to wear belts.
Yeah.
But the Vince and Larry characters were based on actual tools that were being used
Sure.
by the auto industry and the government to try to make vehicles safer. So when I was finishing my engineering school, I saw an article about a switchover. The government was finally upgrading its dummy for regulatory testing. In the 60s and 70s, when crash testing first started being done, there was no standard crash test dummy. And every automaker had their own sort of idea about what a crash dummy should be. At some point, they standarded around something that later became known as the Hybrid 2.
Okay. Is that Vince and Larry?
Well, not really.
They were a Hollywood version of that?
Yeah, exactly. Vince and Larry sort of look like the Hybrid 2, right?
With like the little crosses on their heads and all that kind of stuff.
Exactly. And the big, the big challenge of crash test dummies is to make them durable enough to be tools that you can use over and over again.
Okay, sure. So more durable than a human.
Right, more durable than a human, but at the same time be enough like a human to give you usable information
about what happens to a human.
Exactly. So through the 70s, General Motors had embarked on a project to upgrade the crash test dummy that would be used. And then they asked the government, can we use this new dummy? We think it's got advantages. It's more human-like. It's got more channels of information that we can record in a...
So the government has some control over this at the time? And so they're saying these dummies are sanctioned by us?
Yeah. In fact, the government does sanction dummies that are supposed to be used in showing compliance with federal regulations, right? There's part of the Safety Act is known as Part 572.
Okay.
And that Part 572 basically defines all of the tools that are used by the government to test whether or not automakers are in compliance with regulations.
What are some other tools? There's crash test dummies. What other like motion sensors or something, or what else would there be?
It's mostly crash test dummies, but there are regulations addressing equivalency between motion sensors. For instance, that was a big issue in the late '80s, early '90s. Was the regulation says government labs are going to use an NDEVCO 7264 accelerometer.
Okay.
You can use anything that's equivalent.
Okay.
But at the time, no one had written down what equivalent meant.
Yeah, that's a loose word.
So there is a standard defining what is equivalency.
Yeah.
There are also some crash carts. I forget what today's test is, but in some of the tests, the vehicle under test gets hit by something that's got four wheels and a crushable face.
Yeah.
But it's not a real car.
Okay.
It's meant to represent a car. So 572 also.
And that was all in place in the 80s, 70s?
So some of the parts of that 572 were in place, and 572 at the time only defined the so-called Hybrid 2 dummy.
Yep, okay.
And GM had come up with a Hybrid 3 dummy.
Okay.
Which they thought was a better mousetrap.
And that was so your background is biomedical engineering,
Correct.
and these are biomedical engineers. This is one of the things the biomedical engineers do, is they design crash test dummies.
Yeah, well,
cool.
I didn't know that until I stumbled across this article.
Yeah, it wasn't on the list of things like, hey, you're in high school, you should go.
Exactly. When I was finishing engineering school, I was thinking I would be in the medical devices industry.
Yep.
But I saw this article about crash test dummies. I thought, it's kind of interesting. I kind of like cars, and it seems like the stuff that they would have to deal with in designing crash test dummies and interpreting measurements from crash dummies would be related to stuff I learned in engineering school. And what happened in my particular case was that I mentioned this a couple times in conversations, and
to friends and family.
Right? And the idea that I wanted to be a crash test dummy engineer got around to an aunt.
Yeah.
Who knew somebody who worked for US DOT, in particular the National Highway Traffic Safety Administration, at their lab in Central Ohio.
Right.
And at the time, they were looking to fill a position.
Huh. And where were you at the time, geographically?
I was graduating from Northwestern University.
Okay.
So I had grown up in Cleveland, and I was at Northwestern.
Okay.
And so
the Ohio Government contractor network.
Yeah,
Who knows?
So,
Yeah.
so my aunt called my mom and said, I understand Dave wants to be a crash test dummy engineer. I talked to this guy.
I can hook him
know.
up. Yeah.
They're looking for a person. David should send a resume to Howard Pritz.
Wait a minute, you can get my son a job. Shut up. Yes, done.
And so I sent a resume, and it got passed on. I eventually had an interview, and my first job out of engineering school was working at a company called Transportation Research Center of Ohio, which has got its own long history. But at the Transportation Research Center of Ohio, which is located in East Liberty, which is about 50 miles north of Columbus, there was also the Vehicle Research and Test Center of the National Highway Traffic Safety Administration.
Yep.
So there was a resident lab that belonged to and run by the federal government on this big facility.
Doing crash tests.
Yeah, right.
Using the dummies.
Right. And
So building the dummies, did they get made in house? Like who makes this stuff?
I'll get to that in a minute.
Okay, sure.
Just to finish
Yeah.
So my job was, with TRC, I was a contracted employer to support the work of USDOT.
Okay.
At this research facility. Yeah, we worked with dummies. We didn't make them.
Yeah.
But as part of the work that we did, crash testing and other experiments using dummies, we took them apart.
You break them.
Yeah, took them apart, put them back together again.
Yeah.
Trying to
Okay.
figure out better ways to use them.
Yeah.
Those kinds of things.
So what were they made of at the time? So what was the state of the art in the crash
So
testing?
what they're made out of hasn't changed all that much.
Okay.
Generally, the skeletons are made out of metals
Okay.
like steel and aluminum.
Like Wolverine.
Yeah. And then they have coatings that are made of different kinds of plastic or rubber materials.
Okay.
To represent the skin.
Yep. Like Terminator 2, Terminator 1, T800.
Possibly. There are, if you get a chance to look at the dummy lab, you can see, for instance, that the ribs are these bands of thin steel, but then glued to the bands of steel is this plastic material that sort of makes the rib less springy, because the living human bone is not as springy as steel hoop.
Yeah, okay.
Right.
Interesting.
And so there are these kinds of things and the neck, for instance, your neck is made up of, 7 vertebrae,
Yeah.
hard bones that are connected by ligaments and muscles and so on and so forth. No real pins or anything in between them. The dummy's neck there are two styles. One is a series of rubber discs separated by metal discs, and then the rubber discs have different diameters, and some of them have cuts in them to give the right bending.
Right. So
Characteristic.
they move similarly
Yeah.
to a human.
And then there's another.
Which part's rubber, which part's metal? So just thinking the vertebrae are the metal parts, and the rubber are like the discs in between.
Yeah. So in that particular neck, there isn't a 1-to-1 correlation between vertebrae and
Right.
and
Some
the-
other structure that's
Right.
equivalent to
Exactly.
like the accelerometers.
Right. And so and then the other dummy that we have is specially designed for looking at neck injuries, and he's actually got a plastic vertebrae for each of the vertebrae in your neck.
Yeah.
In that dummy, the vertebrae are connected with pins, so it's just like a door hinge,
Yeah.
which is not very lifelike.
Right.
But for motion front to back, it does a pretty good job, because there are these little dampers and some springs and some cables that are routed through the neck vertebra to
Right.
give it motion as if it were constructed more like a human neck.
And so how do you account for muscle tension and relaxation during an accident, right? Because it's not a continuous.
Yeah, that's one of the big challenges.
Okay. Because you might freeze, right? And that, you have a different kind of
Yeah.
set of resistance in your neck than you would if
Right.
you're just kind of loose.
Yeah, and that issue has been known for a long time, but we haven't really come up with a good solution for how you represent that in a crash test dummy.
Yeah.
Because the crash test dummies are still, even the latest versions, are passive devices.
Yep.
And so in tuning the squishiness of the ribs or the bendability of the neck or what have you, there's a sort of a compromise between what we know from experiments done on
Cadavers. Yeah.
which are dead and don't have muscle tissue,
Yep.
and what we know from experiments involving lower levels of force on volunteers.
Yep.
Or just asking people to, pick up weights or something like
Sure.
that to try to get some sense of how that influences. And so the passive qualities of the dummy are sort of a compromise between what we know about living tissue and what we know about dead tissue that is exactly the same shape and size.
So this must be a big problem in measuring whiplash. I'm thinking is that a condition that's hard to kind of figure out with these dummies?
Yeah, whiplash is especially complicated injury to understand because whiplash is essentially defined as the symptom following the injury.
Sure.
People receive some kind of violent insult to their neck, and then they complain of pain.
Yep.
In most cases, that pain resolves itself within a few days or maybe a couple weeks, with something as simple as taking aspirin.
Yep.
But I think it's like 1 in 10 cases, people persist having pain or dizziness or ringing in the ears for months after the injury. And the exact nature of what tissues are damaged is still not
maybe none.
completely understood. Well, that complicates things, right? Because you'd like whatever you do in the lab to represent what really happens in the real world.
Yeah.
But the signal that you have from the real world
Not-
is
not
contaminated
perfect.
by people either exaggerating or completely bluffing the
Yep.
injuries.
Trying to get an insurance claim. God forbid.
Right? So, the biomechanics is pretty clear that you can do injury to the neck.
Yes.
The nerve tissues, the muscle tissues, and even the skeleton.
They can be injured.
in
They are vulnerable. Yeah.
Right. But what they call, I think the sequelae is what they call it medically, the consequences of those injuries, it gets fuzzy and linking, a certain type of pain to a certain damage to a certain tissue is something that is still being studied.
Mm-hmm.
So the way we've approached it in our work is, there is this basic idea that if the head and the neck and the body all move together so that there's no bending of the neck, there's little chance of any of the tissues in the neck becoming injured.
Yep.
Right? So that was the inspiration in the 1960s to require cars to have head restraints.
Yep.
And in fact, there are several studies that showed when cars started being required to have head restraints, the incidence of neck injuries following a rear crash went down.
So head restraint is just the pad at the back of the
Just
seat?
the pad at the back of the seat.
Yeah.
Now, the regulation that went on the books was not very good. Mainly, the two critical things were that it didn't require head restraints to be tall enough to cover everybody who might be riding in a car.
Mm-hmm.
And it didn't require the adjustment to lock in place. So we've even got some video that we did with a crash test dummy where you've got the head restraint adjusted to its fullest position. Looks pretty good, like it might actually catch the head. But the dummy's head hits it and he pushes it all the way down and you end up with this big bent neck.
Yeah. Pretty ugly to see.
So we did a series of tests showing that some head restraints did a better job of preventing the neck bending than other head restraints, and then built up a vehicle ratings based on that.
Mm-hmm.
And as automakers changed their designs to comply with our requirements for a good rating, we did another study and found, neck injury rates went down again.
Wow.
For good versus poor. So I tell you that story mainly to make the point that despite the fact that we know that there's exaggeration and fraud in the claiming of injury for necks, we also know that there's real injury, and we also know that we've been able to address it. Even though we don't know exactly what's happening inside the neck to cause these symptoms that people complain about.
You got the outcome you wanted with the process that you demonstrated therefore to work.
Right.
So how about the progression of the crash test? I mean, so hybrid 2 to today, or hybrid 1, I suppose, to today, what are... Is there a standard now? I guess is one question.
Yeah, so the current crash test standards use mainly what is still the hybrid 3 dummy. There are two sizes written into regulation. One is the average size male, and the other is the small female. For side crash test regulations, there's a separate dummy,
Right.
which is known as the EuroSID, for European Side Impact Dummy. That is the basis for crash test regulations. There is a new generation of dummies that, for frontal crashes, is known as Thor, and for side crashes is known as WorldSID because it was developed by a world consortium. Those dummies have been under development for something like 20 years.
Wow. What's so hard about it? Is just getting people to agree on stuff, or
That exactly.
social
Trying to get
problem.
everybody
Not
trying to get
engineering.
everybody to agree on stuff.
on what? Like, what would they be disagreeing about?
Well, I mean, it's, how much attention needs to be paid to the fidelity between the dummy response and the reference cadaver response. Or the
But as long as
reference
it's
volunteer.
better than the prior version, surely you say, okay, keep going. Let's do another one
Well,
next year.
exactly. I mean, when you're working within a similar organization or in a single organization, right? You can more easily say, okay, this is enough better. But if you've got bunches of organizations and one's working on the neck and another one's working on the ribs and the one's working on the hips, you have the situation where not
Right.
everybody's working in sequence, and so the
don't see
rib
the
guys
whole
may think they're finished, but the shoulder guys say, "Hey, wait a minute, we see a problem with,"
Yeah.
and so it never gets resolved.
And so Hybrid 3 is still in place.
So Hybrid 3 is the dummy that is used in all regulatory testing.
No, that's not what you use, though.
We do use the Hybrid 3 in our frontal crash tests. We are currently running experiments with the Thor dummy
Okay.
to see whether or not using the more advanced dummy gets us better information.
Why Thor? Thor is in, like, the thunder god?
Well, Thor stands for, what does it stand for?
Something that spells Thor, which is an awesome name for a dummy.
Yeah, it's an acronym that has something to do with the thorax.
Okay. Okay.
So it's not related to.
Do you modify them? Are there sensors inside these dummies? I mean, what's with the technology? Do you have to do you change it up for, because your crash tests are looking for different kinds or more information, I would suspect, than the regulations require?
Yeah, I mean the biggest customization that is done typically on the dummies is the complement of sensors that you put inside.
Yeah.
So yeah, we measure things that are not part of regulation.
Yeah.
We measure things that we don't even evaluate, that we're just sort of measuring, sort of forward looking.
Sure.
Is there some day we can make use of this new measure?
Totally. Yeah.
And so that's the. There are other changes.
Are there electronic measurement devices inside? Like, do you hook up a USB cord to the dummy and download data? Like, do you do that, or
Yeah, exactly.
You
Right.
do?
Yeah.
Oh, cool.
I mean, and today most of the dummies have a solid state recorder inside.
Yeah.
And so the wires
Black
are relatively
box.
right. Yeah, a black box. It's blue, but it's same
Same
thing,
idea.
Same idea. So the wires are relatively short, connecting the sensor to the recorder. Mm-hmm. But that's only been possible relatively lately.
Sure. Yeah.
So in the early days, there were big long wires
Okay.
that connected
Inside the dummy.
Inside the dummy, that
Right,
went
like-
out of the car into a recorder,
Okay.
typically magnetic tape,
Yeah. Sure.
pulled along in a trailer
A lot of failure
that was
points here.
attached to the car. Yeah, exactly.
Yeah.
And then, some indoor crash testing labs had big long cables that went to a recorder mounted on the floor in the lab. And then I think Ford was one of the first companies to shrink all of that recording equipment down into a size that would fit in the trunk. Mm-hmm. And then when we built this lab here, we bought a recorder that was completely solid state, and it was about the size of a loaf of bread.
Yeah.
And could fit inside the chest of many dummies.
Yeah.
Not the smallest ones, but certainly mid-size and above. And now we've got a solid state recorder that's about the size of a cigarette pack.
Now
so-
it's smartphone parts.
Yeah.
Right. I mean, you
Right.
have cameras and stuff in those things.
Yeah,
At some point, you got to
exactly.
think, right?
Right.
Maybe do you have accelerometers inside the dummy?
Yeah, so there are accelerometers. There are what we refer to as load cells that measure force, and most load cells are based on what in engineering is known as strain gauge technology. So You apply a very thin piece of foil, and that foil has a property that when it's stretched, the resistance changes.
Yeah.
So by measuring the resistance going through that piece of foil, you can estimate the force if you know the shape of the thing it's attached to.
Yeah.
And so there are a bunch of load cells that have these strain gauges glued in certain configurations that allow you to measure force in different positions, the force applied to that piece of the dummy.
How much of the internal anatomy do you use as kind of like a inspiration for where you put stuff? I mean, do you think about that at all? Like, to what degree are these dummies aside from physical outward appearance and some mechanical capacity, is there anything else inside it like that's similar to?
Yeah, so past the rib cage, nothing really
Yeah.
resembles a human being.
Right.
All right, but the sensors, there are a lot of sensors around the rib cage because
Sure, you got a lot of stuff in there that's pretty important.
exactly,
Yeah.
and that's one of the kinds of severe and fatal injuries that people suffer in the more severe crashes. There's a
Yeah.
lot of instrumentation in the neck and the head.
Yep.
Measuring the motion of the head gives you a way to interpret what might have happened to the brain. And then there's a lot of sensors in the legs because when the occupant cabin starts to collapse, the legs are the first thing
Yeah.
that's sort of in the way.
I mean, we're hopefully see some video on this as part of this series of media I'm putting together. But man, it's amazing that people are going
Right.
to walk after some of this stuff, and obviously they cannot.
Yeah, and
it's
there's not much instrumentation in the arms yet. Arms do get injured in crashes, but
Sure.
they generally the injuries to the arms are not life threatening, and so not much attention's been paid to them over the last 50 years of crash testing.
How about perception? How about like, does how somebody feel in a crash at all relevant here, or is this just kind of insults and impacts and stuff? Do you think about? Maybe it doesn't matter. It happens so fast. I know, like what they see and I don't know, hear. Does that kind of thing matter?
So, I mean, I'm not sure the role of emotion.
Sure. Right. Yeah.
Right. You mentioned hearing, and there are aspects of the ears that are important. One of the things that automakers learned early on about airbags was that if you're driving around in a car with all the windows closed and you suddenly inflate a big several liter balloon, you create a pressure wave inside the car.
Okay. Wow. Right.
And in some instances that can cause damage to the ears. So I think Mercedes recently has got some kind of, like in the event that the airbag's about to fire, they do some sort of a pre-noise that triggers some
Right. Some like protective response.
Yeah, reflexive response inside the ear to make it less susceptible to the pressure change injury.
Amazing. That's pretty cool.
The other thing that came out of early airbags, for instance, and you may see it in today's crash, but there's sometimes smoke comes out of the airbags.
Okay.
And the smoke today there's much less smoke than there used to be, and it's less irritating than it used to be because the airbag inflators now have lots of filters.
So there's like a detonator in there. Is there that triggers the?
It's
inflation?
basically like an explosion.
Okay.
It's a pyrotechnic device that gets a electric shock.
It burns.
It burns really quickly, creating a bunch of gas that fills up the airbag.
Right.
But some of the combustion byproducts are irritating to people's respiratory system. And so, there were in the early days there were tests, to find out what was the nature of the smoke that's coming out of the airbags, and do we have to filter that to make sure that we don't cause anybody respiratory distress as a result of having been in a crash where an airbag deployed.
So let's come back to the question I asked a little while ago. Who makes the dummies?
So who makes the dummies? Right. So right now there is pretty much only one company,
Okay.
and it's a company called Humanetics.
Okay.
It's headquartered in Michigan,
Where in Michigan?
in the Detroit area.
Okay.
I
Yeah,
think
good enough.
between Detroit and Dearborn. I can't remember
Right.
where their headquarters.
Center of the automobile universe
Right.
for many years.
Right. Now, but that has changed over the years because going back again to the 70s, there were at least 2 or 3 companies. There was Alderson Research Labs, and there was a Humanetics early generation, and there was something else, and then there were some like mergers
Yeah, sure.
and other companies going out of business. At the time that we built this research center, there were primarily two companies. One was called Vector Research in Toledo, Ohio, and the other was First Technology, and they were in the Detroit area. And I can't remember if they combined or whether one just went out of business, but we're in the current state of there's just basically one company.
And so these companies only make crash test dummies, or do they make other stuff?
They make some other stuff. So Humanetics now makes a lot of the sensors
Okay. Sensors that go in the dummies?
that go in the dummy, right?
Okay.
And its predecessor company didn't make sensors, but they acquired the company that was making these load cells that I mentioned,
Makes
which
sense.
are custom made to fit in the different parts of the dummy. They provide calibration services for both the sensors and for the dummy parts themselves, and they do make other related test equipment, a lot or laboratory equipment that's intended to help take care of the dummies over the life of the crash test dummy.
And are these dummies only used for car crashes, or are they used for other things too?
So the dummies that we use are primarily used only for car crashes. They occasionally get used in testing of aircraft frames.
Yep.
But there have been efforts in the last probably 20 years by the military to develop dummies that were specially designed to measure the forces of concern in aircraft crashes or IEDs blowing up underneath tanks.
Right.
where the insulting force is coming from a different direction. And
Yeah.
so you have to think about,
You care about different stuff.
you care about different stuff, exactly.
Yeah. And motorcycles, any point?
So people have
dad.
tried doing motorcycle crash tests with dummies, but they're not really good for that.
Yeah. Boats?
Boats, as far as I know, there isn't a
There's
whole
not a whole
lot.
lot of human safety stuff in a boat.
No, there
Wear
aren't.
your life jacket.
Yeah.
You get flung out
As far
of
as I know, nobody crash tests boats on purpose.
Okay. Yeah, we do it for fun. A few beers. How long do crash test dummies last?
They last for several years, and,
Okay.
and although I often say, at the end of 10 years, it's possible that the dummy with serial number 123 is essentially got all new
Sure, yeah.
parts, because
Yeah.
at some point you break something or it wears out. Or it goes
Not
out of
dissimilar from a
commission.
human, they say. After 7 years, your cells will regenerate, you're a whole different kind of being.
Right, so,
Yeah.
but,
You do that on site here, so you'll do custom maintenance on the.
Yeah,
those?
we do the maintenance. We send some of the stuff out, some of the more complicated and less frequent things that need to be done to take care of the dummies we send out.
Yeah.
But most of the stuff we do.
What's a new dummy cost? Or do they like a subscription plan?
Well, I haven't tried to buy one. They're in the neighborhood of $70,000 to $100,000. The new generation, these Thor dummies, when you add all the instrumentation and data recorders, are $1 million.
Wow.
But the ones like the
Better
Hybrid
get 10
3
years out.
family that we've been, that a lot of people use are an order of magnitude less expensive.
Yeah, that's amazing. That's
Yeah.
100,000 is. I was gonna guess 10. I was thinking about whether I would just try to say 10. That's a big number.
Yeah.
Yeah, and that's just the materials. I guess they gotta make them by hand, right?
Yeah, I mean they're essentially made to order.
How many do they make a year?
I
Do
don't.
you think?
I would. It's probably less than 100
Yeah.
full dummies a year.
Yeah.
Would be my guess, but
Yeah.
I'm not exactly sure.
Who else buys them? So the
So the
government
automakers make them. The government agencies make them.
Yeah.
There are other organizations like us around the world that
Yeah.
may have different funding mechanisms, but there are other organizations that do crash testing independent of the government and independent of the automakers. And there are around the world several contract facilities like the TRC where I first went to work. Mm-hmm. Although I worked in the division that supported the work of DOT, a lot of that company's revenue was generated by work it did for automakers or part suppliers, or in even some cases lawyers and insurance companies that are trying to generate data to defend some kind of a lawsuit.
Would they rent a dummy? Can that be done?
Yeah, so you can buy a crash test, right?
Yeah.
You can go to TRC of Ohio or MGA is another company or CalSpan in Buffalo, New York and say, hey, I've got a question that I think would be answered by a crash test. I've got a budget to run it.
Yeah, which would be several $100,000, one would think.
Yeah, exactly.
Test. Neat. Well, I mean, probably should go back to the group, but anything else about your role that we have with these crash test dummies? What else do you do here?
Well, in my role, I'm sort of responsible for overseeing and coordinating all of the research activities. So
Okay.
that extends from the testing that we do here at the research center
Yep.
to the analyses that Matt's group does
Yep.
involving the insurance data. And we've a group of researchers who aren't in Matt's group and aren't at the research center, but do research using either data that is publicly available, like the fatal accident reporting system data, which the government collects, or works with contractors to generate unique data sets. So we're a member of a consortium at MIT, for instance, that is gathering on the road vehicle motion and driver behavior data for cars that have new technologies, trying to understand how people use these new cars. We do studies involving infrastructure, road infrastructure. A lot of work on roundabouts, for instance, showing that when you replace a traditional intersection with a roundabout, you reduce.
Do you?
Yeah,
They're better.
They are better.
Yeah.
And they're better from the transportation engineering standpoint because in a lot of applications, traffic keeps flowing.
Yep.
And it self-adjusts. If parts of the day heavy traffic is in one direction, and other parts of the day it's in another direction, it sort of takes care of itself.
Yeah.
Whereas,
But if you're in like 3 a.m, sit there at a red light, being like, "What on earth am I doing?"
yeah,
here?
exactly. You can
Yeah.
just drive through the roundabout.
Yeah, that's cool. So, I mean, these different data sets, that's pretty unique, I think, perspective on auto safety you guys have here. Probably
Yeah, I
nobody
think
else
one of
can
the
match
things
that.
that's unique about IHS and Hildy is the fact that, we're not just vehicles and we're not just, behavioral policy interventions and we're not just insurance data, but we're involved in all of that.
Yeah,
And have been, for the course of our existence.
Mm-hmm.
And in the last, I would say, 15 years, we put a lot of effort in trying to, do analyses that use both the insurance data on the one side and other data from another side to get more insight than we could by using the data sets in isolation. So.
and you're a think tank, I suppose. Is that what the right way of thinking about this organization? Funded by private organizations, by companies?
Yeah, I mean, we do some think tanking.
Yeah, publishing papers.
But mainly, we're trying to do research,
Yep.
and the research, I think there are two big veins in the research. One is sort of research that helps describe the problems caused by crashes in enough detail to point to possible solutions.
Yep.
And then the other part of the research is if we can find countermeasures that have been implemented somewhere, test whether those countermeasures are making a difference.
Yep.
And then alongside the research, we also have a very strong communications effort,
Yes.
so that the research doesn't just sit on a shelf.
Yeah.
So a lot of times, when we do research about automated enforcement or roundabouts, for instance, we try to get that in front of as many people as possible so that DOT planners considering new, road building will consider roundabouts, or communities that are having problem with red light lane crashes might consider automated enforcement, those kinds of things.
So, final question. If you could change one thing about either behavior or regulation or technology or something that you could do today, we could do today, the government could do today, companies could do today, what would it be? What's the lowest hanging fruit for highway safety?
Well, probably the lowest hanging fruit would be getting people to obey traffic laws, including speed limits.
Yeah, okay.
It's not necessarily the easiest problem to solve.
I mean, it's not so hard. You just put sensors on the bridges, on the things,
Yeah,
and you can
you
get every
could
single
today
person.
build a car that won't exceed the speed limit.
Yeah.
But it does require a great deal of political and public desire to do that.
Yeah.
And there is a strong current in society, especially here today. People wanting to be free to do
Yeah,
whatever
sure.
they want.
Well, yeah.
and even disregard the law.
I want to get to where I'm going faster.
Yeah, right.
I have to say, I asked the same question of Matt when I interviewed him, and my instinctive response to that was, "Damn it!" And that's probably what people were saying, because you're in a rush. Like sometimes, and these are the problems, obviously, right? But I do get that's that's a problem. That's a problem with our behavior.
People's behavior is the big People's behavior is the big problem, and it's not that people are driving around wanting to crash.
Of course not.
It's just that in enough
they're
circumstances,
not wanting to crash enough.
Right. Well, exactly.
Yeah.
Right. Not wanting to crash enough to moderate their behavior when there's pressure from other
Not being
parts
aware
of it.
enough
Yeah.
that crashing can happen.
Yeah.
And that's that's one of the great things I look forward to seeing today is what happens when it crashes. Brings it to mind.
Right.
Thanks very much, Dave.
Yeah, you're welcome.